students. Today I am going to discuss the next important topic from the chapter chemical bonding and molecular structure, that is polarity of bonds. Okay, there are two types of molecules, homonuclear molecules and heteronuclear molecules. Okay, homonuclear molecules and heteronuclear molecules. What is the difference between homonuclear and heteronuclear molecule? Yes, please listen. H2, Cl2, Br2, O2 are examples for homonuclear molecule. In the case of homonuclear molecule, the homonuclear molecule is formed by the combination of two similar atoms. Okay, H2 is formed by the combination of two hydrogen atoms. The homonuclear, the nuclei of the two bonded atoms are same. That type of molecules are called homonuclear molecule. Cl2. Okay. Yes, Cl2 is formed by the combination of two similar atoms, that is chlorine atoms. But HCl is an example for hydrogen chloride, is an example for heteronuclear molecule. Here it is formed, HCl is formed by the combination of two different atoms. Okay, then the nuclei of these two bonded atoms are different. H2O is a heteronuclear molecule. Okay, that means if the nuclei of the two bonded atoms are same, the molecule is called a homonuclear molecule, or we can say the molecule which is formed by the combination of two similar atoms are called homonuclear molecule. Then if the nuclei of the two bonded atoms are different, or if a molecule is formed by the combination of two different atoms, the molecule is called a heteronuclear molecule. Then if a covalent bond is formed between two similar atoms, the bond pair of electron is equally shared. This bond pair of electron is equally shared between these two bonded atoms. The reason is that the electronegativity of these two bonded atoms are same. What is meant by electronegativity? What is meant by electronegativity? Yes, electronegativity is the ability of a bonded atom to attract the shared pair of electrons towards its side. Electronegativity is the ability or capacity of a bonded atom to attract the bond pair of electron or the shared pair of electron towards its side. Here the two hydrogen atoms having similar electronegativity or the capacity to attract the bond pair of electron is same, then this bond pair of electron is equally shared between these between hydrogen atoms, and here in this case the bond pair of electron is equally shared between two chlorine atoms. Such a covalent bond is called non-polar covalent bond. Non-polar covalent bond. Then what is meant by non-polar covalent bond? If a covalent bond is formed between two similar atoms, the bond pair of electron is equally shared between two atoms. Such a covalent bond is called non-polar covalent bond. Homonuclear molecules like H2, Cl2, etc. having non-polar covalent bond. Then, if a covalent bond is formed between two different atoms, then the bond pair of electron is displaced towards more electronegative atom. Here, the chlorine is more electronegative than hydrogen. Okay, the chlorine is more electronegative than hydrogen. Okay, chlorine is more electronegative than hydrogen. Then this bond pair of electron, yes, shifted towards this electron cloud, this bond pair of electron, shifted towards the more electronegative chlorine. Hence, electron density around the more electronegative chlorine atom, this more electronegative atom increases. Okay. Okay, then the chlorine attains a slight negative charge. Slight negative charge, it can be indicated by delta minus, and the electron density around hydrogen atom decreases. The hydrogen attains a slight positive charge, delta plus. Okay, if a covalent bond is formed between two different atoms, the bond pair of electron is displaced towards more electronegative atom. Hence, the electron density around the more electronegative atom increases, and it acquires a partial negative charge, delta minus, and the electron density around a less electronegative atom, in this example the less electronegative atom is hydrogen, decreases and it attains a slight positive charge. Okay, thus a partial ionic character arises in the covalent bond and is called polar covalent bond. Example HCl, H2O, HF, etc. Okay? Yes. Second example is H2O. We know in H2O, the central atom is oxygen. Oxygen is bonded by two hydrogen atoms. Oxygen is more electronegative atom. As we move from left to right in a period, the size of the atom decreases and its electronegativity increases. Here oxygen is more electronegative atom. The more electronegative oxygen attracts the bond pair of electron towards its side. Then the oxygen, then the more electronegative oxygen attracts this bond pair of electron towards its side. This electron pair, this bond pair of electron move towards oxygen, and hence the electron density around the oxygen atom increases and electron density around the hydrogen atom decreases. Okay. Such molecule with this type of molecules with partial ionic character are called polar molecules. Then homonuclear molecules like H2, Cl2, Br2, etc. are examples for non-polar molecules. And heteronuclear molecules like HCl, HF, H2, etc. are examples for polar molecules. Yes, next term, important term related with the polarity of bonds, that is dipole moment. Its symbol is mu. What is meant by dipole moment? The degree of polarity of a covalent bond is expressed in terms of dipole moment. ഒരു മോളിക്യൂൾ എത്ര കണ്ട് പോളാർ ആണ് എന്ന കാര്യം നമുക്ക് ഡൈപോൾ മൊമെന്റ് യൂസ് ചെയ്തുകൊണ്ട് എക്സ്പ്ലെയിൻ ചെയ്യാം. വാട്ട് ഈസ് മീൻ ബൈ ഡൈപോൾ മൊമെന്റ്? ഡൈപോൾ മൊമെന്റ് ഈസ് ദ പ്രോഡക്റ്റ് ഓഫ് magnitude of charge. The product of magnitude of charge, its symbol is E. Magnitude of charge can be indicated using the symbol E, and charge developed on any of the atom and distance between the atoms in a covalent bond, D. But dipole moment means what? Dipole moment is the product of magnitude of charge developed on any of the atom, that is E, and distance between the atoms in a covalent bond, That means dipole moment mu is equal to E into D. For example, in the case of HCl, okay, already we know the chlorine is more electronegative, then this bond pair of electron displaces towards chlorine. Chlorine attains a slight negative charge and hydrogen attains a slight positive charge. Delta plus and delta minus. Here the dipole moment can be calculated, yes, multiplying the magnitude of the charge developed on any of the atom, okay, chlorine or hydrogen, and the distance between the bonded atoms. Distance between the bonded atoms, and the unit of dipole moment is dB. dB D. Okay, dB is the unit of dipole moment. That means the polar character of a molecule increases. The value of dipole moment also increases. Then how can we represent or indicate the dipole moment? Okay, dipole moment is indicated using an arrow. Dipole moment is indicated by an arrow having a plus sign, on the tail, and the arrow must be pointing towards the negative end. Okay, dipole moment usually indicated by an arrow having a plus sign on the tail, like this. Okay, plus sign on the tail, and okay, it is written above the molecule with the arrow pointing towards the negative edge. Example, in a HCl, the negative edge is chlorine, delta minus, and the arrow must be pointed out towards the more electronegative atom for negative edge, that is chlorine. Then, in case of homoatomic molecules like H2, Br2, Cl2 have zero dipole moment. Dipole moment is zero. Hence, these molecules are non-polar. These molecules are non-polar. For non-polar molecule, the dipole moment is zero. Molecules like H of HCl, etc. has large dipole moment due to the greater electronegativity of fluorine and chlorine than hydrogen. Yes, in HCl, the chlorine is more electronegative than hydrogen. And at the same time, in HF, fluorine is more electronegative than hydrogen. Yes. Then these molecules, the molecules like HCl, HF, etc. have large dipole moment value. Okay. The dipole moment of HF is about 1.91 dB. Okay, 1.91 dB. Then the next important point, greater will be the electronegativity difference between the atoms in a molecule, greater is the dipole moment. Okay, when the electronegativity difference between the bonded atom in a molecule increases, the dipole moment value also increases. That means its polarity, the polar character increases. Okay. Next important point, for polyatomic molecule, what is maybe polyatomic molecule? The molecules having more than 2 atoms. Okay. Here, the different hydrogen halides are placed in this table. Hydrogen fluoride, hydrogen chloride, hydrogen bromide, and hydrogen iodide. The electronegativity of halogen. The electronegativity of the halogen fluorine is 4.0. The electronegativity of chlorine is 3.0. The electronegativity of bromine is 2.8. and the electronegativity of iodine is 2.5. That means what? Yes, fluorine, chlorine, bromine, iodine. Yes, this is the 17th group elements. As we move down the group, the electronegativity value decreases. Electronegativity of halogen decreases. Then this electronegativity difference increases. Electronegativity difference increases. Then we can observe the greater electronegativity difference in HF, since fluorine is more electronegative atom. Yes, HF. Here HF is more polar, okay, and HF has greater dipole moment, that is 1.91 dB. Okay, then here, yes, as we move down, yes, the electronegativity difference decreases. Then then polar character increases, the dipole moment value also decreases. Okay. Next we can consider polyatomic molecules. What is meant by polyatomic molecules? The molecules having more than 2 atoms are called polyatomic molecules. Okay. H2O, NH3, CH4. Okay. Polyatomic molecules. For polyatomic molecules, dipole moment is the resultant of vector representing various individual bond moments. For polyatomic molecule, dipole moment is the resultant of, okay, vectors representing various individual bond moments. Okay. For example, in BF3, what is its resultant bond moment? Please listen, in BF3, fluorine is more electronegative, then the bond moment, the arrow point towards the more electronegative fluorine. Here, the dipole moment of BF3 is resultant vector representing the various bond moments. That means here the bond moment in BF3 is the resultant of the bond moments of 3BF bond. That means the 3BF bond in the bond moments add ചെയ്തു കഴിഞ്ഞാൽ നിങ്ങൾക്ക് എന്ത് കിട്ടും? Yes, add ചെയ്തു കഴിഞ്ഞാൽ that is called resultant bond moment. Okay, that resultant bond moment is the bond moment of BF3. Then, in case of molecules possess regular geometry, means what? The molecules having only bond pairs of electrons. We know BeCl2, beryllium chloride, having only 2 bond pairs of electron. Yes, it possesses regular geometry, linear. Then BF3, boron trifluoride, has only 3 bond pairs of electron. It also possesses regular geometry. Its geometry or shape is trigonal, planar. Then CCl4, carbon tetrachloride. CCl4, okay, CCl4 also possesses regular geometry, tetrahedral shape. That means in case of molecules that possess regular geometry, example BeCl2 linear shape, BF3 trigonal planar shape, and CH4 tetrahedral shape, PCl5 we know trigonal by pyramidal shape, SF6 octahedral shape, have zero dipole moment. Very, very important point. Okay, the case of molecules that possess regular geometry means the molecules having only bond pairs of electrons. Example BeCl2 linear shape, 2 bond pair, BF3 3 bond pair, trigonal planar shape, CH4 4 bond pairs of electron, tetrahedral shape, PCl5 5 bond pairs of electron, shape is trigonal bipyramidal. Then S of 6, 6 bond pairs of electron, its shape is octahedral. These molecules have zero dipole moment. Please listen. In BeCl2, the bond moment pointed towards more electronegative. Chlorine, these two bond moments pointed in opposite direction. It cancels each other. Okay, these two vectors indicating the individual bond moment cancels each other, and hence is the net dipole moment, the resultant dipole moment is 0. Then next BF3. Here in BF3, this bond moment and this bond moment, these two bond moments, okay, pointed opposite direction. Okay, in the same manner here, this bond moment and this bond moment pointed in opposite direction. These bond moments cancels each other, and the dipole moment of BF3 is 0. Then next CCl4. CCl4, the bond moment pointed towards the more electronegative chlorine. Okay, in carbon tetrachlorate. Yes, these two carbon chlorine bond lies in the same plane. Okay, we know this carbon chlorine bond, okay, pointed towards the observer. This carbon chlorine bond lies away from the observer. Here, these two bond moments, this carbon chlorine bond moment and this carbon chlorine bond moment, which lies in the same plane, cancels each other. Okay, like this carbon chlorine bond and this carbon chlorine bond. This carbon chlorine bond, this bond pointed towards observer. Okay, then this carbon chlorine bond, this one lies away from the observer. This bond moment and this bond moment, these two bond moments, okay, yes, directed in opposite direction. Then these two bond moments also cancels each other. Then the net dipole moment becomes 0. The net dipole moment becomes 0. Yes, then CCl4 possesses regular geometry, tetrahedral geometry. Its dipole moment is 0. Then molecules having unsymmetrical structure. Means what? The molecules having bond pair and lone pair of electrons possess a definite dipole moment. Example, NH3. Ammonia has one lone pair and 3 bond pairs of electrons. H2O has 2 lone pair and 2 bond pairs of electrons. Okay. These molecules possess unsymmetrical structure. Okay. Then yes, molecules having the unsymmetrical structure like H2O, NH3, etc., having a definite dipole moment. Okay. Then you please read this question, important question. Although fluorine is more electronegative than nitrogen, the resultant dipole moment of NH3 is greater than that of NF3. Give reason. Listen, we know both NH3 and NF3 have pyramidal structure. Okay, NH3. In NH3 and NF3, the central nitrogen atom is surrounded by 3 bond pair of electron and 3 bond pair of electron and 1 lone pair of electron. Okay, hence both NH3 and NF3 have, these two molecules have pyramidal structure, and the central atom has a lone pair of electron. Then NH3. In NH3, we know nitrogen is more electronegative atom. Yes, nitrogen is more electronegative atom. And here the individual bond moment pointed towards nitrogen. Pointed towards nitrogen. Okay. And the lone pair of electron. Yes, the bond moment due to the lone pair of electron. That means here in NH3, the bond moment due to lone pair of electron, this bond moment due to this lone pair of electron, okay, is in the same direction, of the resultant dipole moment of these three NH bond. This is the resultant dipole moment of three NH bonds. Okay, this is the bond moment due to the lone pair of electron. Okay, then in NH3, the bond moment due to the lone pair of electron is in the same direction of the resultant dipole moment of 3 NH bond. Hence, NH3 has high dipole moment. The dipole moment of NH3 is 1.47 dB. Yes. But in NF3, we know the fluorine is more electronegative than nitrogen. Okay. Then the bond moment directed towards fluorine, and NF3 has one lone pair of electron. This is the bond moment due to the lone pair of electron. Yes. Then in NF3, the resultant bond moment of 3 NF bonds. This is the resultant bond moment of 3 NF bonds. Okay. Then the bond moment due to the lone pair of electron, yes, directed in opposite direction, and hence partially cancelled each other, then NF3 has very small dipole moment value as compared to NH3. Its value is about 0.24 dB. Yes. Okay. Then this is in NF3, the bond moment due to the lone pair of electron is in the opposite direction to the resultant dipole moment of NF bonds, the resultant dipole moment of NF bonds, and hence partially cancelled by each other. Dipole moment of NH3, dipole moment of NH3 is greater than that of NF3. Okay, students, in my next video I will discuss the next important theory related to covalent bonding, the molecular orbital theory. Okay, students, goodbye, study well.